Today our topic is KNN. So KNN stands for nearest neighborhood classification. And what is the basic idea about that one? The basic idea is about the distances, like how one instance is near to another instance, or how one object is near to another object. So usually we use distances, Euclidean distances, or Manhattan distances, and there are a lot of variety of distances over there. So the basic concept is the proximity. So proximity means like you're around about who is lying around you. So for example, if there is a basic idea is that if it walks like a duck, quacks like a duck, and then probably it's a duck, right? So computer usually works like that one, that how it looks and how it behavior. So based on the behavior or based on the distances, we predict. Now, usually, as I told you that in the KNN algorithm, what we see, we usually use the Euclidean distances. So I would like to, yes, highlight this for you. Yeah, Euclidean distance is the main idea, and you see the distances. Like for example, what is the distance of this object with this one, and what is the distance of this object with that one, right? So these are like near the proximity, right? So if I just uh, circle the plus one, so these plus will be near to each other. So that could be a one cluster, okay, and that could be in another cluster, okay, and this could be in another cluster, right? So based on that one, we can predict some more instances. For example, if there is one more plus here, okay, so we can make the circle a bit bigger, and that could be the part of that cluster. Okay, so majority voting is one of the technique to check that which one label will go for it, right? So usually it looks for the weight of the vote. So more the weight and that distance is chosen. So weight factor is usually given by W equal to 1 divided by D square. So as you know that D is a distance. Uh, for some of the data scientists, they believe that distance is not like a recommended one, while the cosine theta means you might have studied in the trigonometry. The cosine theta is the best, attributes to measure the similarity or to measure the proximity, right? So in the example, if you look at here, just let me highlight this for you. If you see over here, a Euclidean distances for both of these data. For example, if I find the Euclidean distances between this data and that one, okay, and this and that one, two data sets, right? So the Euclidean distance is the same, although the data is different, right? So that's why we go for cosine similarity measures. Why we go for that one? Because cosine is for these two is different, and for these two data is different, right? That's why cosine is considered to be a better choice instead of the Euclidean distances. Okay, so usually in all kind of algorithms, we do some pre-processing, or we call cleansing of the data. Attributes may have to be scaled to prevent distance measured from being dominated by one of the attributes, right? So there could be different attributes, like for example, you can check the height, okay, of a certain object. You can compare the weights of the different object, you can compare the income of a person, right? So one attributes might be interfering with another attribute. So there is like a certain criteria at the end of the slides. I will let you know that which should be chosen and which should not be chosen. And moreover, there is a tip for time series kind of data. For that one, the standardized is, they say that mean should be 0 and standard deviation SD should be 1. So usually when you start KNN, you choose a random point, basically random point anywhere. Like for example, if I choose this is my random point. So So this is my random point. From this random point, I will check the proximity of this point. I will check the proximity of this point. Okay, I will check the proximity of this point. So we will keep some distance. So for example, our distance is, let's suppose, 1. Okay. So the one, whoever in the distance 1, that will be my cluster, right? So this is like, uh, how it looks like. And there is some, like, sensitivity cases, like if k is too small, sensitive to the noise point, so k should be like, more, to have, like, to avoid the noise. And if k is too large, like the neighborhood may include points from other classes, so the k should be not be too small and not be too long or too, like, large. Okay, so there is another way that, for example, in this kind of Venn diagram, we fit, like, 1 point in the different, like, diagram. If you see over here, so each and every one has, like, this cluster has 1 point, this has a 1 point, okay, and this is another point, right? So they have, like, variety of points over there. So nearest neighborhood classifier are local classifiers. They can produce decision boundaries for arbitrary shapes over here. So this is one of the special case of the clusters. And then we say that how to handle missing values in the training and test data. So as you know that we need cleansing and how to remove that one. So there is an example in Python. I will show that how the missing value has been removed, and there is a special functions. For example, if there is a value not applicable, or nan, na, and name, so how to replace with the mean value. So I would show you that thing. And also this is like, for example, handling irrelevant or redundant attributes. Sometimes some attributes are noisy and they are not, like, helping in the proximity of it, and how which are, like, creating the noise, means like which is irrelevant, and this could be like, so the redundant attributes bias the proximity measure towards the certain attributes, right? So it means that certain attributes which are, like, noisy in this case, or what are the noisy attributes? So is, if you look at here, these are, like, noisy attribute. They are not contributing for the clustering, and these are discriminative attributes. They are, like, discriminating into the two classes, class A and class B. Now here is, like, sample clusters showing you which is me being made by the KNN classifiers, and in the different colors, like red colors and the blue colors. There are certain attributes that might be interacting. So there is a specific pattern you can see over here. For example, if this is class A, so after that one class A is repeating, and then class A is again repeating. For example, if it is class B, right, so it is interacting with the A, and there is a specific pattern for the B. And similarly for this one, okay, and similarly if you start with the B as well, right? So this is like, how two classes are interacting and how we can handle in the graphical shape. So the last slide, which is talking about that, like how we can improve the KNN efficiency, we can do it, like, avoid having compute distance to all objects in the training sets, right? So, like, you should not, like, include all the objects. You should be more selective. In case of, like, multi-dimensional axis method, so you have to be selective, and you should not all use all the dimensions of that one. And you should also see that there is another technique which is called fast approximate similarity search, uh, that which attribute will be helpful to find out the predictions through similarity. And the last one is called locality sensitivity hashing, which is mostly depending on the probabilistic approach. uh, and then we have, like, second important thing is the condensing determine a smaller set of objects that give you same performance. Like sometime uh, same performance can be achieved through a small set of attributes rather than the large set of attributes, so we go for condensing. And editing could be also be helpful, that sometimes we remove objects to improve the efficiency. Sometimes some objects are not, like, helping, so we remove it, right? Now let's see some example from Python, that how the KNN can be involved or can be simulated. So I have certain data over here. This is the data. For example, this is the medical data. For example, about diabetics prediction. So these are like, for example, pregnancies month. This is about the glucose level. This is blood pressure, skin thickness, insulin level, BMI, body mass index, and this is about genetically, if someone father or dad has a diabetic problem. This is about the age, and this is your classifier, like outcome, whether this person has a diabetic or non-diabetic, right? So 1 and 0. So 1 means diabetic and 0 means non-diabetic. So if I import this data into the Python, I'm using the Kaggle over here, and the code is already made over here. So if you see over here, we need this code, this libraries to be imported. So most of the library you might be aware of it, like NumPy, pandas, Metaploid, right? These libraries you are already aware of that one, and you have used in your labs. Okay. Now the second thing, this is your the data imported, and it has been put into the data frames. And this is EDA, exploratory data analysis, EDA, just to tell that what are the ranges, what are the glucose ranges, what are the blood pressure ranges, what are the insulin ranges. So it tells you about explain the data, okay, through simple this one line code. So info is one line code, okay. You can use for any other data as well. If you have it, you can use it, okay. And similarly, there is another one line describe, okay. So for example, you say diabetes data dot describe and bracket, it will tell you about that, how many counts are there, how many mean, what is the standard deviation, minimum, maximum value, all this it will describe you the data. And similarly, like this more description of the data over here. So let me jump to the KNN algorithm, because I'm more interested in the KNN, than how the KNN works, right? So this is like more like visualization, that how we visualize the data, age, BMI, blood pressure, insulin, and outcomes, right? So outcome is usually two, 0 and 1. So either it's a diabetic or non-diabetic, right? Okay, and then we see that NAND removal. So NAND, this was like called plotting after the NAND. NAND means the not available data. So how to replace the not available data with the mean value. So there is also a short code for you. You can see it. I will show you. And the skewness of the data, some data is skewed left and some are skewed right. Okay, and here you can see for example, count of each data type, how it looks like, okay, some more visualization of the data. I am just running to the specific code which is related to the KNN and how the KNN looks like. And in this way, on the diagonal you can see the data is is the ideal data over here. And also on the diagonal, look at the data which is like more ideal. And here you can, in the heat map, you can also see the 1 1 the data. So that's why I call it the ideal data. And there is like scaling the data. Scaling data means like more cleansing of the data. You clean the more data. Um, okay, so why we need it? So there is a description. You can read it for understanding. Okay, they use cross validation of the data. Why cross validation? Because sometimes this training 70% of the training and 30% is the testing. So might be the training and the testing uh, is not the maybe there is overfitting and underfitting. So why we choose different chunks from the training, so that there is no biasness. We do validation so that in the real time it works well, okay. Sometime in the testing it looks good, there is no error, but in the real time, in real hospitals, when we check it, it is not giving the exact value which we need it, right? So prediction, look at this one. This is very important library, sklearn. As I told you that this is for use for the deep learning or for the machine learning. Okay, so this one is k-near neighborhood algorithm which we use it, right? And this one, it will tell you that at which value the results will be like a good one. So we